So here we are. So we're looking at the code from the Programming Pro book. And so we're looking at the first one, the first little exercise. It's a script called Create Feature Layer. And I'm not going to type everything for all of them. We're just going to kind of review some of the solution code. So here we're importing arcpy. We're setting a workspace to that City of San Antonio geodatabase. And now what we're doing is we're making the feature layer. So this is what it looks like. And notice that we're also using a try statement for error checking, but we are creating a new layer, on the burglary layer, which is that same layer that we were looking at here. This is burglary. So make a feature layer on that burglary feature class and call the output burglary layer. And in this case, we are setting it equal to a new variable in my code called flayer. So there are a couple of ways you can do this. You don't have to do this on the left. You could put your layer name in here as well. It's just another way to do it. So that's how we would create that in-memory layer on a feature class. If you had a standalone table, then it would look like this. Here we have our table, the name of the table, and then the string representing the output table view. And then this is a variable that would represent that output table view. So the table view is just like the feature layer, but for a table. And with the try statement, we have looked at arcpy.getMessage or arcpy.getMessages. So what he's doing here is the exception. He's printing out an error, an e.arg0. This is going to return basically the same thing as you would from arcpy.getMessages. It's just a different way to do it. So that's pretty simple, just making a feature layer. Now let's take it one step further. Okay, so this is basically the same code, but now we're building on it. So now we're going to be running select layer by attribute. And the way the select layer by attribute works is we need the input layer, which is flayer. And then we need our selection type. And then we need our query. Okay, so what are the selection types? If you look back at the help here, and they're actually the same for the select layer by location. So we'll just look at this since it's where we are. What type of selection do we want to create? We want to make a new selection because we don't currently have anything selected. So in here, I would literally type in as a string, new selection. And that's it. And then my query. So I could enter in my query all in here, but it would make my line of code for this tool really long, left to right. So it's a little bit better if you make a string for your query up above somewhere and then just pass in that variable. So what do we want to pass in? Let's go back to here. So we want to find all the points where DOW equals Friday or Saturday. So we're just going to copy that and paste it in. If you know SQL really well, you could just type it off the top of your head. If it's more complex, or if you're not sure what the field name is, then I recommend working closely with ArcGIS Pro to get that so it's correct. So notice that I pasted it in, and we have an open quotation mark here. We have a closed quotation mark here. Our field name is DOW. It is not in quotation marks. Fry and sat are in single quotation marks because they have to be in single quotation marks. And the whole thing is treated as a string because we have that open and close at the end. So that's what it would look like. Yeah, generally, if you don't type it in the right way, it won't be color-coded. You'll get black text in there and it'll look funny. And then you'll know right away that the quotation marks are not correct. So now I can go back and look at this. And now I have my input, my selection type, and my query. And that's it. That's all I need for this tool. Then down here, we're running get count. So we're running get count on flayer, and that will be the number of selected records because that will be the number of records in my selection layer. So if we run this, we'll see what happens. So it finished running And I don't have any other print statements up here, so I don't really have a lot of feedback, but the number of selected records is 10,987. So my only print statement is right here, and it worked just fine. So there we go. So now we have our make feature layer and a select layer by attribute, and we have our try statement in case anything goes wrong. We'll get better errors or messages. Now let's hop into select by location. So we want to select features in the burglary layer that fall within the Edgewood School District, so Edgewood SD. And if we look in here, if we look in ArcGIS Pro in the catalog, we can see we have a feature class here for Edgewood SD. So what we'll need to do in the code is run a second make feature layer. So instead of F layer, we're going to call it O layer for overlay layer. And it'll be the same as above, but it'll be the Edgewood SD layer. And it helps if you spell it right. Okay. Okay, so now we can look for features in F layer that are within a distance of, and either, I think that this would work too. I'm just going to use a variable because we made the variable and I would rather use it. So what we're doing here in step 2 is selecting features in the burglary layer that are within 1 mile of Edgewood SD. And so that's how you would run select layer by location. So we have the layer that will get the selection on it, our spatial relationship, the layer used to help make the selection, and then in this case we have a distance. And there are optional parameters for the select layer by location tool. If we look at the syntax way up here, see, these are all optional. Curly bracket, curly bracket, curly bracket. So if we're okay taking the default, we don't have to put in anything else. We can just leave them off. So selection type and invert, we're just leaving them off. And whatever is listed first in the list in the help is the default. So new selection is the default. So by leaving it out, that's what it will do. Okay, and who remembers how to make the selection become its own feature class? What tool do we use for that, and how do we run it? So take a second and think about that. I'm going to cheat. I'm going to go back to the slides while you are thinking. Okay, so there it is. There's your proof. So if you forgot, it's in the slides. So arcpy.copyFeatures_management, and then the input layer, and then your output feature class. So I'm just going to copy this, because why not? And I'll go right here and paste it in. And so what is our input layer that has the selection? That's right, it's F layer. And then what do we want to call the output? So we have a workspace set up top. If we want the output to go into that geodatabase, then we can just put in the name of a feature class as a string and it will be put into that geodatabase. So I could do Berg near Edgewood. So this could be the name of my output feature class. Close the parenthesis, and that's how I would run that. And it's commented out right now, but this is how we would get the count of the number of features in F layer, and it would look like that. And here's the rest of our exception here to get the errors if there are any. So let's take one more quick look. I'm actually just going to jump into the solution instead of typing all the code, but I just want to show you how you can also play around with some different types of SQL expressions. But if we look in the databases folder, and it's not sitting anywhere in a geodatabase, it's just a shapefile right out here. I'm going to add schools to my map and zoom to it because it's actually in Austin. There are some schools. If I look at the attribute table for schools, and if I take a look at the verified field and sort it, I'll see two things. one, a lot of them are blank. And then I look how I have no lowercase and no capital. And I have Y lowercase and a few, somewhere in here, there are a few Y capitals. I can't find them now, but I think they're in there. When you do a SQL statement or a SQL expression, the value that you are looking for is case sensitive. So if we look back at the slide here, if we look back at like county equals Larimer, if the L is capitalized in your table, then you have to put it capitalized in your SQL expression. So if you don't have consistency and if you don't have good standards in your table, then your SQL statements might not find the features that you're looking for. Same thing goes for typos, and that's a more obvious error. But you don't know if people type things differently, if people spell things differently, if people abbreviated things differently. So when you're doing queries, you might have to account for how things were entered in if they were not entered properly. So let's take a look at this verified field, yes or no. If you wanted to make sure that you got both lowercase and capital Y's, you would have to actually enter that in with your query. So here's an example of that. Here we're making a query statement. There's the verified field, and now we're using in. So there's a SQL operator called in, which lets you choose multiple values, and the values that you want to look for are provided in parentheses, separated by commas, and then each individual item has its own quotation marks. So if you were in ArcGIS Pro and tried to run that tool, so if I tried to find something here, here's my schools. And I want to find features where verified includes the values. So when you're in here, you don't see the word in, you would see includes the values. So that means I want to say verified has one of these values, and then I get to check the box, lowercase, uppercase. And then I just check the boxes, hit OK, and this is what it gives me. Verified in lowercase or uppercase. So use this query builder to your advantage for sure, but that's what we're doing here. If you know that you have multiple values or you're afraid that you might have multiple values, they have to be accounted for in your code. The other way to do this is really annoying. So if you don't know about in, you might be thinking, oh, well, I'll just type it in like this. Verified equals lowercase or uppercase. What do you think about this? Has anyone ever tried this before? I bet you have, and I bet it didn't work because that's not how it has to go. It wouldn't be exactly this. It would be verified equals Y lowercase or verified equals Y uppercase. You actually have to have that field name in each instance in order for it to work. So if you have a lot of values, let's say you have 5 different possibilities, you'd have to do verified equals A or verified equals B or verified equals C and so on. So in just saves a lot of typing. So once you have that query, then I'm passing it into here and it will catch either uppercase or lowercase. Let's take one last quick look at the like operator. Address. Maybe I'm trying to find schools where the address, contains something, contains the text Marcos, because I'm not sure. Sometimes it's San Marcos, sometimes it's S Marcos, or maybe it's spelled differently, and I want to catch all the different possibilities. So I can do this. And then if I look at my SQL syntax, look what it gives me. Address like %, Marcos, %. And then actually, I just realized when you type it into here, you don't need quotes in here. There. So now address like Marcos. So I could paste this into PyCharm, and I could make this a query. But remember, it also has to be a string, so you have to put the quotations on either side. So this is a query that I could pass in that would get anything that contains Marcos. So just keep in mind that any type of SQL statement you can do in ArcGIS Pro, you can do in here, but test it out in Pro before you do it in here, because it's a lot easier to troubleshoot in Pro than to run your whole script and not really know what went wrong. And the last thing I want to show you, I keep saying the last thing I want to show you, if I were to run this, I could run this whole tool and it would run and it would make my selection on the map. If I like what I see, then I could also copy the entire Python snippet for the whole command and put that into PyCharm. So if I run any tool and then go to my catalog, go to history, it'll keep track of everything I've run. So right click on it, copy Python command. I showed you guys this once before, but here it is again. Copy Python command and then go to PyCharm. Now, instead of having to type out all the code, like in line 26 here, I can control paste and it puts all of it in there for me. So that's a really quick way to get complex code written for you. So that's all I wanted to show you. So let's hop to the end here. What you're going to be doing now for the lab, you have some really fun data to work with. There's a little group activity for you, but then the self-directed activity, you have the pleasure of working with my roadkill data. So you're going to be writing some code to answer a few basic spatial questions about the roadkill data. Each of these 915 lovely points are species observations, most of them being roadkill. So you'll get to answer questions like, how many points did a certain person answer or collect? How many points are within a certain distance of a road? So you'll get to play around with queries and writing code and writing a complete script to answer some stuff like that. And that's all we have for this part of the lesson on selections. Keep watching the next video on calculate field, and then after that, you'll be ready to do the lab. Thanks for watching and happy coding.